Hey, how's it going, guys? Today we're going to be doing a tutorial looking at how to recreate this fun swing dancing rope thing. Um, and we're going to be going over it from scratch. So we're going to be sourcing the animations from Mixamo, taking that into Houdini to do our simulation, and then lastly we'll take the results of our Houdini simulation and move it over into Blender and do our rendering there. All right. So the first thing we're going to need is to get that dancing animation, right? We're going to get that from Mixamo.com. If you're not familiar with this website, it's an Adobe product and you do have to have an Adobe license. But if you've got like Photoshop or Illustrator, you should be able to get in to this website. And it's really nifty. So they've got all these different animations and characters, and you can download them as FBXs. So for our purposes, first off, I want to pick my character. Let's see. So there's all different characters, but for the thing we're doing today, we're not actually really going to see the character. We just kind of need the basic humanoid shape. So I'm going to pick this mannequin. And then I'm going to head over to the animations tab, and we can do a search for dance. And you can see we get all these different dancing animations. It's nice. It's all in 3D, and if they've got these little sliders for controlling different aspects of the animation. But for our purposes today, I've decided I'm going to do a swing dance sort of thing. So I think it's this one. Yeah, which is cool. So we're just going to hit the download button. You can set the format, but we're going to do FBX binary. I know that we're gonna do our rendering at 24 frames per second, so I'm just gonna go ahead and set that, and then definitely gonna get this with skin. All right, so that should take just a second to download, and then we're gonna head over into Houdini. All right, moving over into Houdini. So we're gonna recreate all this from scratch, but before we do, I just wanted to give you kind of an idea of what the network is gonna look like. So you can see it's really not that bad. We've got a node to bring in our character. We're going to scatter some points and generate the lines on them, do some stuff with some colliders. And the big thing here is we're going to simulate it with Vellum. Lastly, we'll extrude the wires, give it a little bit of shape, and then export it out to Blender. Cool. All right, so let's get started. Let's make this thing from scratch. So I'm going to come over here, and I'm going to drop down a FBX character import. All right. So the first thing is we just need to find that file that we downloaded from Mixamo, and here we are. Now, this node's got three outputs, right? It's got rest geometry, capture pose, and animated pose. So I'm gonna drop down an all just so we can look at what each one of those look like. So the first one is literally just the geometry, our dude in T-pose. It's not animated at all, right? Now the next one here is our capture pose. And again, it's not animated, but these are like the bones. Like these are the things that we can actually use to deform our character, right? And the last one is animated pose. And this is where the fun is, right? So we got the dude actually dancing, right? So if we want to see the character or use those bones, we can use a bone deform. So the first thing here is geometry to deform, which is our rest pose. The next one here says rest point transforms. So we're going to bring in that. And then lastly, it wants deform point transforms. So if we do that and hit play, we can see we got our dancing dude, right? All right. So we don't actually need that right now. But what we do want to do is scatter a whole bunch of lines across this guy like that. Those are going to be our ropes. To do that, I'm going to drop down a scatter, bring that over, and you can see we've scattered a whole bunch of points over our dude. So I'm going to drop down a line and then a copy to points. We're going to copy our lines onto our points. Okay, so the first thing you got to know about the copy to points is it orients the things that it's copying based on the z-axis. So our line here by default points up into the y-axis. So we're going to move that over to the z And then just to make this a little bit easier, we're going to shorten this just so we can kind of see what's going on. So we've got a whole bunch of lines on our guy, right? Now, for the moment, you can see we just have 2 points. And we're going to need these lines to be all bendy and floppy, right? So we're going to need a lot of more points. Now, the easiest way to do this would be to just drag the number of points up, and then that would give us a lot more points. But I'm going to do this slightly more involved way. We're going to instead resample, and we're going to set the maximum segments. So this is, we'll just take each line and put 10 segments into it. For our purposes, I don't know, I'm going to say 50. We'll see how that goes. But the big reason that I want to use this resample node instead of just adding the points there is that we can get this curve U attribute. It's going to be helpful a little bit later. If we look at the geometry spreadsheet, we can see the curve U here. It just starts at 0 and works its way up to 1. And basically what that's saying is, for each one of these points, how far along the curve is it, right? So at the very beginning of the line, it starts at 0 and then works its way up to 1. We're going to use that a little bit later in the network to control the width of the lines, depending on where we're at in the line. All right. So one thing we need to do here is we're going to end up anchoring these lines to our character so it can dance around, right? And for that, we're going to need to know which point should be anchored. So we're just going to drop down a group node here. We're going to call our group anchor. And then we're going to say we're using points. And then we're just going to use 0.0. So you can see the very first one there is orange and all the other ones are blue. That just means that this group is that. And then that'll carry over for when we copy our points. We'll have that group that'll say the beginning of each one of these lines is the anchor group. Okay, so moving right along. Now we can get to some of the fun of like actually simulating this thing. So first things first, we're going to drop down another bone deform. And we're going to deform these actual lines here. So instead of deforming the character, we're going to deform these lines. So we're just going to bring those down. And now we can see that our lines are doing their dance, right? They're not simulated. They're not being affected by being floppy or anything, but this is the start of it, right? So from there, we're going to add a config Vellum hair. So this is, we're going to use the Vellum, which is a really nifty simulation thing inside Houdini. And before we can use it, we need to like actually get it set up and tell it, how things should be configured, right? And then next we need to set up a solver, which will actually take the dynamics and do their thing. Now, so for this one, I'm going to click on the first output and hit tab. And I'm going to say Vellum solver. And the reason I do that, let me go back to the beginning here. The reason I do that is it just quickly hooks up all 3 outputs, so you don't have to connect them one at a time. Okay, so if we turn the display flag on for that, yeah, there we go. You can see all the lines fall. And, that's not exactly what we want. Also, it's running really slow. So just to kind of start off, I'm going to change the number of points that we're simulating down to, say, 100. Just to play around with and make our lives a little bit easier. Okay, cool. So now we've got falling hairs. Woo! But obviously, we don't want the lines to fall. We went to all that trouble of setting up our anchor group. So over here in the Vellum hair SOP, if you come down here, you can see pen to animations. and it'll say which points to pen. We're going to pick our anchor group there. And a quick note, if you don't see that group in the drop-down box, it might just be blank. Just hit the display flag on either the hair or the solver, and then it should show up. All right, so at this point, let's hit the display flag, and now our groups are anchored, right? But they're not dancing, and the reason is we have to hit this little checkbox to say match animation. Otherwise, Vellum just kind of ignores everything. It just brings in what it was in the first frame and it just runs with it. But if we hit match animation, then it'll watch those things move around, and we can see now we've got the start of this guy dancing. So we gotta make some changes, but it's definitely a start. All right, so one thing is, I know from playing around with this that I want my lines to be really, really super floppy. So I'm gonna come down to this bend section, and I'm going to change the bend stiffness down to 0.1 and then drop the order of magnitude by 1. So this just means the lines are way less stiff. They're very floppy. Cool. And then next for our animation here, I don't want any forces. I don't want any gravity pulling these things down, just for fun. So I'm going to turn off the wind. And we're looking at the Vellum solver here. And then for gravity, I'm going to change that to 0. And now if we go back and we play this, yeah, making some progress. All right, so the first thing is I want the lines to be way longer. We were looking at this to start with, and just so we could see what was going on, we had these kind of short, and I'll make these longer. So it looks like a mess. The other thing I notice is that there's not very many points on the head here. So that means once we actually really get this animation cooking, if there's not any real lines up there, we won't really have any, visual definition of the head. So to fix that, I'm just going to scatter some extra points around the head. So I'm going to add another scatter node here. Move this over. We're going to scatter this, but instead of scattering over the whole body, I'm going to pick my group here and then make sure that I'm selecting points, and then I'm just going to box select most of the head here and hit enter, and then that'll use that as a group, and we'll just scatter a bunch of points up there. We don't need 1,000. I'm going to turn that down to 75, and now we've got something to work with here, right? So I'm going to merge our original points with our new head points and move that into the copy to points. So that way we've got more lines coming out of the head, and visually I think that'll look nicer a little bit later down the line. So let's push that back up to kind of long. Now let's see what we get when we look at the Vellum. Oh, sorry. Gotta actually hit that display flag. Alright, so now we got something cooking. It's definitely in the area, but it lacks some definition here. And the reason it looks a little funny is because while we're moving these lines around, there's nothing for them to collide with. So like there's no leg for them to wrap around, or the torso or anything like that. So what we want to do is we have the character that we animated before. I want to bring that into this last input for the collision geometry. That way the lines will they're anchored to the spots on the body, but then also they'll hit the body and wrap around it. We don't want to see the body, we just want it to collide with it, right? So if I turn on the Vellum solver, and then I'm going to go over to the Visualize tab. I don't like seeing the guide geometry and the collision geometry. So if we hit play, one thing you'll notice right off the bat is it's way slower. Like it slows way down doing this. But the other thing is, if we let this go for a little bit, we'll end up having better shaping. The lines we'll be able to see the shape of the body more in the lines because they're kind of running into the body and giving us that definition just visually, so it looks a little bit better. It does slow things way down though. So let's just let this simulate for a few seconds. And we'll stop and rewind. And the nice thing is, when it simulates, it caches the results. So if we hit play, now we'll get a smooth results, and that's this blue line up until we hit the end of it, and then we're back to jagged, right? All right. So one more thing that I want to do here is the ground here. You know, you can kind of see the grid. We've got lines going through that, and for the final animation, you know, I want to have this guy dancing on the floor. I don't want the lines going through the floor. So the first thing I'm going to do is I'm going to add a ground plane. So we're just going to drop in a grid, and you can see that I want to use that as a collider, but I also still want to use the body as a collider, so I'm going to merge those two. So now for our colliding geometry, we've got a ground and our dude dancing, right? So we'll just move that into there. So at this point, if we do that, we can simulate. We'll have a little problem. The lines that are going through the floor are clipping through it, and it messes with the simulation, right? They kind of get stuck and they act funky. So the solution is before we start the simulation, we've got to fix that. We've got to make sure that we're not giving it lines below the floor to simulate, because honestly, how's it going to know what to do with them? So there's different ways we can handle that, but the way I'm going to do it is I'm just going to use a little point wrangle. So we've got our bones coming, or I'm sorry, our lines, and all of these ones below here, I just want to move them up above that. So what we could say is if our point attribute .y is below 0, then set our point attribute's y position to 0. So if we look at that, all that's doing is moving the things that are below that ground plane up. Now, one little problem though is that the the ground plane is actually at 0, which means our points are now like literally coplanar. They're like exactly on it, which will also kind of mess it up. So what I want to do is move the points up just a tiny little bit. For that, I'm gonna tweak the value. I want to be able to tweak the value, so I'm just gonna drop in a little parameter here and say that. And if we hit our little button there, that'll give us an input, and we can slide that around. And then we'll use that variable. So instead of checking if it's below 0, we'll check below if it's quote-unquote ground. And if it is, then we'll set it to ground. And you'll see if we change that, then we can move things up a little bit. We don't need much. I'm just going to put in 0.01. And that just puts them just slightly above ground. So if we run the Vellum solver now, we should see the lines actually act fine. You can see like these lines down here, they're not stuck in the floor anymore. They're sliding along it, and that's really what we were looking for. Okay. So that takes a while to run, but it looks like everything's going the way it should. So we're just going to move on. All right. So we've got our lines, and at this point, we want to start shaping them, giving them some color, you know, making them a little bit more exciting to see. Because like if we can't render just lines, we need some actual geometry to go with it, right? So I'm going to do a polywire. And with our polywire, we can see we've extruded our lines, and if we make the radius kind of small, we can work with that, right? Now, like I said, I I don't really like having the lines be all one consistent thickness. I wanted to add a little bit of a curve to that. And the way I like to do that, there's different ways of doing this, but I like to do this again with a point wrangle, where we're going to define a p-scale. We're going to make a new p-scale property, attribute on there. We're going to say, we're going to use a ramp here. I'm going to call it curve, and I'm going to use that curve view property that we had before. So if you remember, we did this resample thing so that we could use the curve view property. This is where we're actually going to use it. So that, and I want to multiply it by size. So if we hit this little button here, what we can get is it lets us define a curve, which is cool. And then we can set a size. So I don't know, let's just say 0.1 to start. All right, so we've defined an attribute, but we need the polywire to actually use that. So instead of using the wire radius and just defining one, we'll say at p-scale, and that'll use the attribute p-scale. And that's the one we just made in here. So that's too thick for our purposes here, so I don't know. Let's say 0.08. Sorry, 0.008. Yeah, it looks reasonable. And then our curve here, I want to select everything, and I want to make those B-splines. So you can see that this actually changes the shape of our lines. So we start off at the root here, and then we move down the length of the line. And if we brought this up, you can see that the ends of the line would get thicker. So again, there's lots of ways to do that, but I think it gives the lines a little bit nicer look for what we're doing here. All right, so other than that, I also want different colors for each of these lines instead of them being all the same. So the way I want to do that is with an attribute randomize. And up here where we're making our points, I'm going to drop that in here. And I'm going to say that this is a random value that we're going to use for a color ramp. And I'm going to drop the dimensions down because I just want like one value. I don't want a color value or anything like that. So that means that each one of these points is getting a different random color ramp attribute, right? So if we run that through our solver, now we can use a color node. I'm just going to drop that down here first. And instead of doing a constant color, which would let us set the colors, but every one would be the same, instead we're going to do a ramp from attribute. And we're going to say that we're going to use that color ramp attribute that we just made. So this is cool. Like, if we change that around, we can change our colors, right? So we could actually set the colors here in Houdini, but the thing is, I'm going to be rendering this out over in Blender, and honestly, it'd be easier if we could control the colors from there so that we don't have to tweak the colors in Houdini, then re-export, then re-import, and see if we like it, and then possibly do that a bunch of times. So it's a little bit boring to look at over here, but initially, I'm just going to leave this as a grayscale value. And what that means is some of these lines are going to be black, and some of them are gray, and some are white. But we can use this color value because that will actually import into Blender, and we can use that value to drive the shader over there. Cool. All right, so we're getting pretty close on this. Let's start looking at actually exporting this to Blender. Now, to export it, we're going to use a ROP Alembic. And the ROPs generate outputs, so let's do this. And we can set what we want the file name to be. So I'm just going to call it Dancing Ropes ABC. And you know what? I already made one. I don't want to overwrite it. So another thing is this will, our frame range here will just render out one frame, but we actually want to render out the entire frame range. And by default, these values here, it uses whatever's on your timeline. There's a little expression there, which is cool. We'll use that for now. Another thing to know about this output, it'll save the file, but the name of the geometry that it'll save it is whatever you pipe into it. So in this case, it's polywire. And the thing I found is it's better if you just put a null in here and give it a name. So we'll just call it rope out. Something like that. And the reason I want to do that is if I'm messing around with this stuff in Houdini and then I take it over into Blender and then I realize, oh, I need some other thing. I need to change stuff around. And then let's say I end up putting a different node in here. Like, for instance, a clean node. That'll actually change the internal name of the thing. And then when you go back into Blender, we'll have to change it, and it's kind of annoying. So it's just, I find it makes things a little bit cleaner if I just, before I pipe things into a ROP, if I just give it a null. That way the name is always consistent. And we'll see what I'm talking about a little bit later once we get into Blender. Okay, so one more thing. When it comes to Alembics, it actually supports all the attributes. So if we look at our geometry spreadsheet, having gone through the Vellum simulation and being a character stuff, we can see we have a lot of attributes here, right? And honestly, we don't really need hardly any of them. And we could just write it out, and it'd be fine. The only thing is, though, is all these extra attributes will just make the file sizes way bigger. So instead of just, like, say, writing positions, we're writing positions and orientation and mass and inertia and all this other random stuff. And honestly, these Alembic files can get pretty big, like easily will be into gigabytes of size. And it's just a little bit nicer if we don't have to mess with it being that big. So I'm going to drop down a clean thing here, and I'm going to say remove attributes and groups. And by default, that removes, just about everything. So if we look at our points, you can see all we've got left is point, nothing on vertices and nothing on the primitives. But we do actually want a little bit of this information. So we do want the color. So I'm going to say not CD, this little caret, I think is the name of that one. You can say not CD, and we can see that'll make it exclude it, so we can still have that in our value. So that's cool. Another real quick thing, this messed me up a little bit, is if we look at this, we can see our point count there is 32,988, right? If we simulate this and go to a different spot, let that just cook for a second. Probably shouldn't have gone quite that far forward. And I'm just going to cancel this. All right, if we look at our point counts, it's a different number, right? So this is 33,116. Over here, it's 32,924. And that's because this box here, remove degenerate primitives, is checked. And basically what it is the ends of our lines actually come down to 0, which means there's some primitives there that are 0 area, and it removes them. And honestly, that kind of seems nice, like if we can't see them, why bother rendering them? The challenge will be if the point numbers change coming over into Blender, then the motion blur won't work. It won't be able to calculate the velocities on this stuff, and it just won't work. So in order to fix that, we just turn off that remove degenerate primitives flag. And now if we look at our point numbers, you can see it's 35,700. Move over here, still 35,700. And that's going to be a thing. If we want the motion blur to work, we need to make sure that we're being consistent on that. Okay, so one last thing here is our lines are a little bit jagged. And we could fix that by turning up the resampling and saying more segments. But if we do that, that'll make more work for the Vellum solver, and it will take longer to solve. What we really can do is we can drop down this Vellum post-process and just connect up those inputs. And one of the some of the stuff on this is kind of nice. The post-process is just a node that you can put in after the simulation to make things a little bit nicer. So one thing you can do is detangle. We're not really going to need it here, but detangle will mean that if you have any lines that are like right on each other, it'll shift them around so that they don't intersect. But really the big thing we want to do here is subdivision. Turn that over to Captain Clark, and then just doing a subdivision of 1 looks like that'll be fine. Like when we're looking at this, you know, it's all pretty smooth. So that does give us a lot more points. So where we had 35,000 before, now we've got something like 70,000. But that's fine. It gives us a nicer looking result. Okay, so moving right along. Just cleaning stuff up here a little bit. So one thing that we want to do here is this solver takes a while, and we could just output this now, but I just want to point out that we have this Vellum IO node. Let's just drop that in the line there, and this will basically just cache out the files or cache out all the data for this thing. So which is great. It'll actually literally save it to your hard drive. So that means when we're working with this Houdini file, we can do all the work, calculate all the stuff, and save it out so that if we come back to this Houdini file, we won't need to recalculate that, because it can take, you know, 5-10 minutes to calculate this, right? One thing I want to point out is by default, the files that it saves, like it actually writes to the hard drive, it does that wherever the HIP file is, you know, wherever you've saved the thing. And for me, I like to save my HIP files in a Google Drive, you know, like on my hard drive, and have it sync up. And that's cool. That means I can access my stuff from wherever. But if I leave this like that, these cache files might be huge, you know, like gigabytes. And that means those will also go to my Google Drive, and I don't really want that. So what I'm going to do is I'm going to say move them into this folder, so that way it gets saved, but it's not going up to my Google Drive. All right, cool. So rambled about that enough. Now I'm going to hit save to disk, and we're going to get this little progress box, and it's going to take a while, right? It's simulating all those frames, and it just takes a while. So I'm going to pause the video real quick, and we're just going to let that run. All right, we're back. That took about 4 minutes or so. Cool. So now if we say load from disk, and we flag this guy, now we can see that it's actually baked out the entire animation, which is nice, because so at this point, like if I closed Houdini and then brought it back up, we'd still have this here. Cool. So run that through the rest of it, and we've got all this, which is cool. And this is actually pretty much all we need to do inside Houdini. The last thing we need to do is actually output this Alembic file, which, again, is one of those things that actually can take a little bit. So we're going to say dancing rope, make sure our Alembic file is right, and we'll say save to disk. And we're going to get another one of these progress bars while it does its thing. This one's a little bit quicker, and I'll be with you as soon as that's done. Alright, so that's done exporting, and we can see our file here. We can see that our 700 or so frames came out to be about 1.3 gig. So just know that that's about how big these things can be. They can easily come out quite a bit bigger. I've had Alembic files, you know, in 50 or 60 gig for some stuff. Alright, anyway, so we've got our thing. Well, let's get this over into Blender so we can actually render it out and make something nice looking, right? Alright, so, as is tradition, let us destroy everything in the scene. Alright, first things first, I'm going to hit F3 to bring up the little search thing and type in import Alembic. And then I'm going to go find the file there. So that was Dancing Rope Tutorial. And there we go. That's our little dancing rope. Cool. All right, so let's go about setting some things up here. I deleted it before, but I'm gonna go ahead and just add a camera in, and then I'm gonna go into the camera view by pressing the 0 key on my numpad, and then I'm going to press Shift tilde, which is the little squiggly key to the left of the number 1. And that lets you go into fly mode, so you can use WASD to fly around the scene. So I find that's super handy just to get things set up. Okay, so I know that this is probably going to be something that I'm going to send over to Instagram, and you know, things are generally square over there. So in my tabs over here, I'm going to come over to the output properties, and I'm going to change my resolution to 1920 by 1920. This way I can see exactly what I'm working with and get that set up just out of the box, right? Cool. Alright, so the next thing I know is that I'm going to be rendering this in cycles, not Eevee, for this one. And if you're going to be doing cycles and you've got a GPU, you definitely want to turn on GPU compute. Makes things way faster. Alright, let's see. So if we switch up into rendered view here, we can see our guy here. But, you know, the world is very bland right now. Everything's gray, right? So if we wanted to, what we could do is we could come in here and set up, you know, some nice lighting, right? You know, maybe do a 3-ring light, or, you know, something fancy. However, I am lazy, so I'm not going to do that. Instead, I'm going to go into the World tab, and I'm going to bring in an HDR image. So to do that, I'm going to come over here and then hit the little color and say Environment Texture, which initially it doesn't have one, so it goes to this really fun bright color here. But I'm just going to hit Open. I have a folder for some HDRs. So let's pull this guy in. It takes a second to load it up. But once you have it, you can see this is basically a studio lighting setup. So this is nice because, like, not only do you get your lights, but you also just have some random stuff in the scene for things to reflect, so that you have specular highlights, and, you know, it just gives it a bit more depth to things. Cool. And incidentally, if you're not familiar, you can get these things at, like, HDRI Haven, which I guess nowadays is called Polyhaven. But if you go over there, you can go to HDRIs, and then the studios. These are the ones I really like, because it's some of the same studio lights that you'd end up recreating anyway, and to be able to just grab them off the bat is great. But yeah. Okay, so we've got that. One thing about this scene is you can tell which way the lighting was supposed to be viewed from, because you can see the backdrop, right? So our camera here is not in the right spot. So I'm going to fly back into there and move over, again using number pad 0 and the shift tilde to get into the camera and then fly around. Okay, so another little housekeeping thing here is you'll notice that this orange rectangle, that's what the camera sees, right? And then all this stuff out here is going to be outside the view, and by default, Blender just keeps rendering that. But, you know, if you want to speed things up and don't bother your processor with rendering things that aren't going to be seen anyway, you can come over to the Output Properties tab and hit Render Region. And this is nice because it doesn't waste time rendering things it doesn't need to. Okay, cool. So we've got that going. Next up, let's just add in a ground. And I should say, to bring up the menu, you can hit Shift A on the keyboard, hit Add, and then added a plane. Cool, so that gives us a plane, but I don't want to be able to see this, the HDRI background in the shot. So what I'm going to do is, I'm just going to go back into solid view here, and then with the plane selected, I'm going to hit Tab to go into edit mode. And with this mode, this is where we can like actually edit the geometry, move stuff around. But for purposes here, I'm going to select edges, which you can also use your keyboard to select 1 for points, 2 for edges, or 3 for faces. So I'm big on shortcut keys, so that's how I do most of my stuff. Cool, so we've got this back edge selected. So I'm going to hit E for extrude. And then I'm also going to hit Z, which will constrain it to the Z axis. Which, again, Blender is a little weird. In Houdini, the Y axis is up. In Blender, the Z axis is up. You can see the little origin thing there. Cool. So I also don't want just like a hard edge. So I'm going to select this corner edge, and then I'm going to hit Control B to bevel. And then I'm going to use the mouse wheel to add some sections to it. Yeah, give it a nice smooth geometry there, right? Cool, so I'm going to hit Tab to go back out into object mode. You can see the little tab here changes. Edit mode, object mode. Cool, and then I'll right click on this thing and say Shade Smooth. Cool. Now I'm going to scale this up a bit and grab it and slide it back. Alright, so if we look in our view now, you can see, at least for the moment, we've got a basic thing going, right? Alright, cool. I think next up, let's go ahead and add some colors to this guy. So, with Blender, if you go up to the top right corner of your current window, you can grab and pull down and it'll split the window. So I'm going to change this one over into a shader editor. And then I'm going to turn that one onto a render view. And let that thing get up to speed. Okay, cool. So I'm going to select our geo and then go over to the materials tab and select new. And now we've got a shader editor. Also, when I'm doing shading, look dev stuff, I tend to turn off the overlays, the outlines. You can do that by pressing this button up here. Your view is still editable and all that stuff, but you just don't have to look at the outlines, which can be kind of distracting. Okay, cool. So this right here is our shader for our material for our thing. So if we change its base color, for instance, we could see that reflected. All right, but you know, I don't want just one color for these things. We went to all that trouble to set up some random attributes so that we could have each strand be a different color. So we need to get the vertex colors in. And incidentally, with the object selected, you can come over here to the object data, and in vertex colors, you can see that our CD property actually came over. And for what it's worth, you can actually bring over lots of vertex colors. which can be pretty handy for bringing in extra data if you need to encode extra things. You know, for instance, like if we wanted to have encoded that curve view property so that we could have changed the color along the length of each one of these strings, we could have done that. You can encode all sorts of stuff into the vertex colors. It's actually pretty nifty. But for our purposes, we're just going to be doing a straightforward thing here. All right, so back here in our shader editor, we hit Shift A and say Input, Vertex Colors. You can see CD is in there. So we're just going to bring that in and connect color to base color. Cool, so you can see we've got some black and some grays and white strands. So this is good. That gives us color values that range from 0 to 1, which we can use a converter, and specifically a color ramp, and drop that in there. And now we can actually change some colors here, right? So you can see we could build up our color ramp to be whatever we wanted, and you can see that it's reflected up here. So that's really cool. I think for my purposes here, I'm just gonna do like a blue. Let's say a blue, a white, and a cyan here. So this is a spot, you know, when I make my videos, I often just come in here and just kind of futz around with colors and see what I like. While we're at it, I want to go ahead and set the background color. So I clicked on the background here, the plane, and I'm going to add another material for it. And then I'll often just come in here and kind of just slide around the color wheel and see what color palette I think looks nice. For this one, I'm thinking kind of a blue on blue sort of thing. So, and kind of a darker sort of thing. I think I want a little bit more saturation. Yeah, let's go with something like that. And then I'm going to turn the roughness down because I kind of want the floor to be a little bit shiny or reflective, you know. I'm just going to play around with this a little bit. Yeah, let's go with that. Cool. All right. So that's giving us some basic thing to work with. I'm going to turn the roughness down on this guy too. Make him kind of shiny. I'll always will turn the subsurf up just initially to see. I don't actually like it on this one, but I very often find that I really like the look of having just a little bit of subsurf in there, just to give the objects a little bit more depth. But I'm going to leave that off for now. And yeah, we'll just say that that's our basic setup there, right? Okay, so the next thing is let's get the camera going. So if we look at this guy, he actually kind of dances all over the place. Sometimes he's out of view over here to the left, and you know, just gotta get him set up. All right. So another thing here is I'm gonna want to have the background kind of blurry. I want to have it out of focus. You know, have that depth of field thing going. And if I'm gonna do that, I'm probably gonna want to have my camera kind of far back, which makes our object small. But if we come over to this camera tab, we can, you know, zoom in with the focal length. And I usually like to use something like a 120 millimeter lens for the focal length. That way, this will give us some good separation between the background and our foreground. So we'll come back to the depth of field to play with it later. For the moment, I think I just want to get my framing in. So let's see here. So let's just come to the start of our timeline down here, and then I'm going to hit the record button. And basically, all I'm going to do is just keyframe a bunch of spots here. So for the moment, he's in the center. Actually, I think I'm going to be a little bit closer for that. All right. So, and basically, I'm just going to go down the line, and I'm just going to keyframe you know, some of the big poses here. So for this one, I'll look down just a little bit, get this guy into view. And you can see with our record button on, we're dropping keyframes in every time we make an edit. So that way it shifts. So I kind of got as far over to the right as he was going to get. So we'll move over there. Move there. So you can see we're kind of just going down the line. You can get set up. You'll notice that the timeline here is only going out to like frame 250. So if you use your scroll wheel, you can actually zoom out on the timeline, and you can use the middle mouse button to pan. So I'm gonna just get that so I can more or less see the whole thing. Cool. And just gonna go down the line and take care of business here. Cool. All right. So we'll call that good. Good enough. Like this, setting up the camera angles it's one of those things that you can have a lot of creative freedom on. This one's, we're just gonna do kind of a basic setup here. So we've got that going. If we flip over into the rendered view, we can kind of get a feel for how some of these shots are looking. Yeah, so that's cool. One thing I noticed about this is because our background is really pretty bland, and there's really no details in the ground. When the camera's panning, it's kind of hard to tell that it's panning. So in order to do something about that, I'm just going to add some junk into the background, just to give it a little bit more visual excitement. So I think I'll just add a cylinder. I hit F9 to bring up the properties for this and say 6, so we'll just make a little hexagon sort of thing here. I'm going to bring this up. I'm going to rotate it. So that, and then I'm going to rotate this around so that it's kind of sitting flat. So I'll hit R to rotate, and then Y to just select just that axis. And then I'm going to type in, I think, 30 degrees. Yeah, 30 degrees. So let's just move that back. And one thing, let's see. So I just went into front view, and I know that I'm gonna want to change the size and stuff on this thing. So I'm gonna hit Tab, and just gonna move everything up until the origin is right at the bottom, and then move that down to the ground. So that way I can scale it up and down, and it will always stay on the ground. Cool, so I'm just gonna be looking in the camera view and see where that's at. Let's see, I think I'm just gonna set this hexagon to be the same as the background, which I really should have named this. It's let's go ahead and name this material background. That way we know we're using that. So I'm just going to make it a little bit thinner. And I think I want to get this thing hanging out in the shadows. So I'm going to pop into render view and just make sure it's kind of back there. Cool. Then I hit Shift D to duplicate it. And I'm just going to put another one back there, and I guess I'll scale that one up. And then let's see. So I'm just going to kind of scatter some of these things around. So to move things, I hit G on the keyboard. That's to grab. And then if you want, you can say X, Y, or Z, and it'll lock to that axis. But at the same time, you can also say Shift Z, and that will say move on any axis but that one that you selected. So in this case, I don't want to move it up and down. I just want to slide along the ground. So I hit G to grab it, and then Shift Z to take out the Z axis. And I'm just going to put it down here, something like that. Yeah. So then if I scrub through my view here, there'll just be something in the background that we'll be able to kind of see moving. It's nothing super big, but it just gives it some visual interest. Cool. All right, so with that, let's go ahead and set up the camera focus here. So I've got the camera selected, gone over to the camera tab, and I'm going to hit depth of field. And so this is, like, you can set your f-stop, which kind of controls how blurry out of focus things are, and, you know, in kind of general terms. So if I turn this down, things get blurrier. So one thing, so we have to actually focus the camera, right? So we could try and shift this value around and say, oh, let's see. I don't know. Looks like around 8 meters. This guy is in focus in the background. It's out of focus. And that would work. And you could keyframe your focus while you're moving the camera around. But I find that I have a hard time getting things lined up perfect, you know, and trying to get the real crisp focus. So another thing you can do is, if you come into your scene, you can add an empty. This is like a null if you're in Houdini. Let me move this up, and I'm just going to try and put this more or less in the center of mass of our guy, right? So if I look at this in the front viewport, I'm just going to say, you know, just kind of in the middle of the guy. I'm going to hit 7, go up to the top view. And yeah, that looks like it's about in the middle, right? So what we can do is, instead of setting our distance explicitly, we can use this empty, so as a focus point. So let's go to our camera and set our focus to the focus point. Now that means when we actually render, and give it a second to actually start rendering, you can see that our guy is in focus because that's where the focus point is, and the background is out of focus. If I grabbed that and moved it to the back, you know, like if we wanted these guys to be in focus, we could see we'll get nice sharp edges there, and then our dude would be out of focus. You know, obviously that's not what we want here. So what we can do with that is, now we can just do a little bit more keyframing. So let's go ahead and I'm going to delete this keyframe that was in there, and then I'm just going to go back to the beginning, and I'm in the top view because the height of this doesn't really matter much. So I'm just going to go into the top view here by hitting 7 on my numpad. And then just going to scroll around a little bit, you know, basically like how we did the camera. I'm just going to make sure that this focus kind of always stays in the center of the dude, because that way our guy will stay in focus. It doesn't have to be super precise. So we're just going to go down the line. Yeah, okay, so that's looking pretty decent. So if we go back into our camera view, and then we can head up to our rendered view, and we should be able to get a good idea and see if this is actually working. So again, I'm going to turn off the display so we don't have the thing in the way. And I'm just kind of spot check this, like, gotta move around and see, you know, a sanity check, make sure this thing actually does look like it's in focus at any given moment. And this is looking pretty good. All right. So really, this is looking pretty good. You should save these things at a certain point. I find it super important to save before you render. There was a moment in Blender history where, God, it was like 1 out of 3 chance that if I hit render, the whole all of Blender would just crash and disappear. So I've gotten into the habit. Before I hit render, I always save. Cool. So one thing I want to point out about the render here is you'll notice that we've got our guy here, and everything is in very crisp focus, even though he's moving. So if we render it right now, we'll see that's what we get. You know, like everything's in focus. I'm sorry, everything's very crisp, but motion blur will come in real handy. Like it'll make things look a lot nicer. So if we go up to our render tab, we can just turn on motion blur, and there are some settings in here depending on what you want. For my purposes, I'm just going to leave it at default. And if I hit F12 now and to do a render, hopefully we should see that the lines that are moving will be kind of blurry. So it's important to know that some of this is motion blur and not, you know, depth of field blur. Cool. So that looks like it's working right. We talked about it a little bit when we were back in the Houdini, but in order for motion blur to work, it seems like Blender needs to have the shape have the same point count and the topology to stay the same. You know, there are properties in here. Like if we go to our geo and go to modifiers tab, we have this mesh sequence cache, and it's got a velocities attribute, where to me it looks like I should be able to type in, you know, I should be able to make attributes in Houdini and then use them over here in Blender. And I've heard from some people that they've had that working. I haven't gotten it to work, so if you know how to make that work, please let me know. But as it happens, since we've got all the same vertex counts going on, it'll work fine for our purposes here. Cool. So we're going to call this good, and we want to do a render. So if we come back to our output tab, make sure that our resolution is what we want. This resolution percentage is nice. So like you can say, well, here's my HD, but I'm just going to be doing some renders, and I just want to do like 10% or 50% of it. That way you don't have to keep typing in the new numbers. The other thing is for the output, for our images here, I don't have an alpha channel, so I'm just changing it over to RGB. I turn the color depth up to 16 because why not? And with PNG, I usually don't care about the compression. And then I'll pick a folder, just a temporary folder. Like render. These are all the frames from it, but I'll just say tutorial. So it'll put in this folder, and the thing about this file format is, by default, it's on PNG. You can render the movie directly, so that when it's done rendering, you have like an AVI or an MPEG. I don't recommend doing that. It's a much better idea to just render out the still frames. And if you want, you can use OpenX EXR or whatever. I tend to just use PNG. But just the reason this is nice is because if something happens, if something crashes, like you've rendered 100, like all 698 frames, but you didn't quite get the last one, and something crashes, then you just can't get the rest of those frames. You'll just have to start over, and that's real fucking lame. So I always do PNGs. It's kind of annoying because you have to composite the PNGs back together at the end, but it's worth it. I can't say how many times that has saved my bacon on a job. Cool. All right, so I think just one last thing here is if we come up to our render tab, Blender 3's got this nice thing where we can say our samples, but the thing I really like is being able to just set a time limit. So I can just say, just render for 10 seconds, and whatever you got is what you got. We'll just use that. And then the denoiser is actually pretty good. I've been pretty impressed with the denoiser. So I'm just gonna say 10 seconds on my machine. I've got an RTX 2080 graphics card, and it does pretty good for about 10 seconds on this. So I hit F12, and we're gonna see this thing start to render. And you can see up here it's counting up and how much time it thinks is left. And then once it gets down to 0, then it will do the denoising, which does take a little bit of extra time. So I found when I'm actually rendering the animation, if I say render for 10 seconds, each frame will end up taking me 25 seconds between the denoising and writing it out to the hard drive. But yeah, so here's the denoised version. So yeah, this took 25 seconds. And yeah, this is not bad, sometimes if you don't have enough samples, some of your bits and pieces can get like this weird artifact and noise going on. But for our purposes, this is gonna look fine. All right, so you render all those frames out, slap some music on it, and you should get something like this. Yeah, I'll see you guys next time.